day, this is Angelbert Morales from Philippines, your grade 8 science teacher for today's lesson. Before we start, be sure you have with you your pen and activity sheets. Our today's episode is about Newton's second law of motion. Now, let's have the learning objectives. Number 1. Analyze data to support the claims that Newton's second law of motion. Number 2. Describes the mathematical relationship among the net force on a macroscopic object, its mass, and its acceleration. Second law of motion is also known as the law of acceleration. Newton's second law of motion states that a net force acting on a body produces an acceleration which in the direction of the force. This acceleration is directly proportional to the force and inversely proportional to the mass of the body. Furthermore, the greater the applied force, the greater the acceleration. But the greater the mass, the lesser the acceleration. The different quantities in Newton's second law of motion are as follows: force, mass, acceleration, velocity, and time. The symbol for force is F, big letter F. For the mass, we have small m. For acceleration, we have A, small letter A. And for the velocity, we have victory. And for time, we have small letter t. So these are the symbols for the physical quantities that is present in the Newton's second law of motion. On the second column, we have the MKS, metric kilograms seconds. The unit for force in MKS is kilogram meter per second squared or Newton. In CGS, we have gram centimeter per second squared or we have dyne. Okay. For the mass, in MKS, we have kilogram. For the CGS, we have gram. For the acceleration, we have meter per second squared. In CGS, we have centimeter per second squared. And for the velocity, we have meter per second. In CGS, for the velocity, we have centimeter per second. For the time, we have second. We also have second here. In Newton's second law of motion, it is stated that acceleration is directly proportional to its force and inversely proportional to its mass. It is represented as A is equal to F over M. A is directly proportional to force and inversely proportional to mass. In this case, if we're going to increase the force, the acceleration increases. If we increase the mass, the acceleration decreases. In fact, as we have been stated, if we double the force, the acceleration also double. And if we double the mass, the acceleration decreases into half. We know that as the force increases, the acceleration also increases because the acceleration is directly proportional to its force. We know that as the force increases, the acceleration also increases because the acceleration is directly proportional to its force. If the force applied is doubled, acceleration is also doubled, and both force and acceleration act in the same direction. Acceleration is a vector quantity. Let's prove that when we double the applied force, the acceleration is also doubled. Suppose we have F is equal to 1 Newton and the mass is 1 kilogram. Then we ask to find for the acceleration. Acceleration is equal to force over mass. By simply substitution, we'll be having 1 Newton over 1 kilogram. And this is 1 meter per second squared. Suppose we doubled the force. So F then is equal to 2 Newton. Then mass is equal to 1 kilogram. So we look into the acceleration this time. So we have A is equal to F over M. Then we have 2 Newton over 1 kilogram. Then we have 2 meter per second squared. As you can see, we doubled the force on this part. So meaning to say, the statement is correct. When we double the force, the acceleration is also doubled. A car with a mass of 3,000 kg is accelerated from rest at the rate of 5 meter per second squared. What is the net force applied on it? These are the following given. Mass, 3,000 kg. Acceleration, 5 meter per second
squared.
Then we ask to find F, or the force, applied force. The formula that we're going to use is F is equal to MA. Then we substitute the given value, 3,000 kg multiplied by 5 meter per second squared. Our final answer is 15,000 kg meter per second squared, or 15,000 Newton. Problem number 2. A force of 20 Newton is applied to a 5 kg block that is at rest on a level of a surface.
Find the acceleration produced.
The following given are force equal to 20 Newton, mass 5 kg. Find A. The formula that we're going to use is A is equal to F over M. Then we substitute the given value, 20 Newton divided by 5 kg. Our final answer is 4 meter per second squared. Problem number 3. What is the mass of an object accelerated to 6 meter per second squared by a force of 18 Newton? The following given are 6 acceleration, 6 meter per second squared. Force, 18 Newton. We ask to find M. The formula for M is equal to F over A. Then we substitute the given value, 18 Newton divided by 6 meter per second squared. Our final answer is 3 kilogram.
Thank you for watching. Please don't forget to subscribe and share our video. Thank you. Bye-bye.